All right, guys. So for today, we are just going to do 2 practice problems, and then I'm going to just give you guys the rest of the time to work and practice. So we're going to start with number 5. So number 5 says, a builder is constructing a wheelchair ramp from the ground to a deck with a height of 18 inches. The angle between the ground and the ramp must be 4.8 degrees. To the nearest inch, what should be the distance d between the end of the ramp and the deck? Okay, so below here, we're looking at the ramp that we have. So we want it to be 18 inches tall at the highest point. And we are trying to look for this distance d in which we want that length to be. So what I have right now is I just have a really long right triangle. So if I'm given the angle measure and I'm given the height, how could I figure out what that length would be? So I want you guys to pause the video, take a minute, and try to come up with some ideas. How can we use an angle measure and one side length to find what the other side length should be? So hopefully, as you guys are kind of thinking about this, you saw that since we have an angle measure, I don't know why my pen isn't working. Give me 1 second, guys. Okay, so since we're given one angle measure and one side length, we should be able to use one of our trig functions to find the opposite or find the leftover side. So if I'm looking here, I want to figure out which trig function should I use. So I want to figure out what's my opposite, what's my adjacent, what's my hypotenuse. So 4.8 degrees is my angle. If I go across, that's going to be my opposite. Across from my 90 degree, that's going to be my hypotenuse. So that leaves my adjacent to be this bottom side. Okay, so what I'm given is I'm given my opposite and I'm looking for my adjacent. So which trig function uses opposite and adjacent? That's going to be my tangent. So I say I have the tangent of my angle, so 4.8 degrees equals my opposite over adjacent, so my 18 over d. So in order to solve this, I want to use cross products. So I'm going to put my tangent over 1 and do my tangent of 4.8 times d. And then my 1 times my 18. Well, I'm trying to solve for d, so now I'm going to have to divide both sides by my tangent of 4.8. So when you guys type this into your calculator, you should get that this is approximately, and we're rounding to the nearest inch, so it's going to be approximately 214 inches. And just like yesterday, if you are not getting the right value, make sure that you're in degree mode, not in scientific or radian mode in your calculator. All right, so the next thing that I want to talk about is this idea of angle of elevation versus angle of depression. So in geometry, you guys should have talked about this a little bit, but I want to hit kind of what it is again. So think about if you were to like hold your arms out straight forward in front of you. And if I asked you to elevate one of your arms, you should be lifting it up. And if I asked you to depress one of your arms, you would think to push it down. So really, that's what we're thinking about when we're thinking about angles of elevation and angles of depression. And one of the biggest things to remember is we are always, always, always going to start with a horizontal line. So anytime we're looking at angles of elevation, angles of depression, we always start with the horizontal piece. And then if I say that I'm elevating something, then I'm thinking, okay, now I have a piece that's drawn up. So this is going to be here, my angle of elevation. Oh, that's not how you spell elevation. And so now if I want to do an angle of depression, just like with my arms, I'm going to pull it down. And so now this piece down here, this is my angle of depression. All right, so I want you guys, again, read this problem and see if you can kind of come up with the piece, like what would the angle of elevation be for this problem. And I do want to point out, as you guys are reading, I know this picture is a little intricate, so we are looking at this angle right here. So go ahead and read that, see if it makes sense, and go ahead and try to set something up here. Okay, so this problem says Archimedes was a Greek mathematician that lived around 250 BC. During the siege of Syracuse, Archimedes destroyed enemy ships using reflectors to set them on fire. Find the angle of elevation from the reflector to the sun if the enemy ship was 2 miles from shore. And then we also know that the sun is 92 million miles from Earth. So what we're thinking in this diagram here is that we are 2 miles from the ship to the shore, and we are 92 million miles from our reflector to the sun. So I'm going to redraw this triangle out here. So I have that right triangle. If I were to just kind of draw in that line here from the sun to the boat, that's going to be our 90 degree. This is my 92 million, and this is my 2. And I'm trying to find the angle of elevation from the reflector to the sun. So what I want to do is first I want to find where that reflector was. Well, it was down here with our mirror. And I'm looking for where that elevation is to the sun. So I'm looking from my horizontal piece up to the sun. So I'm looking up. So I'm looking for this angle down here. So right now, if this is the angle that I'm looking for, this is going to be my opposite, my hypotenuse, and my adjacent. So which trig function uses adjacent and hypotenuse? That's going to be my cosine. So if I'm looking for an angle that I'm going to call theta, I'm saying that the cosine of theta equals adjacent over hypotenuse. Okay, so if you guys remember from Monday, when we were trying to find an angle, I can't just say, okay, the cosine of something equals this. I actually have to use one of my inverse trig functions. So instead of using the cosine, I'm going to use the inverse cosine of my adjacent over my hypotenuse. And what this is going to solve is this is going to give me my angle. So anytime I'm trying to solve for a side length, so a side is when I'm going to use the top one. If I'm looking for an angle, that's when I'm going to use the bottom one. So in your calculator, you should be able to just hit the second and then the cosine button, and then type in our number. Again, make sure that you are in degree mode or else it's going to give you an incorrect answer. But you should get that theta is approximately like 89.9999875. So this is going to give us a really, really large number, something that's really, really close to 90. But one thing that we want to keep in mind is be careful with rounding this one. So if I said theta was 90, then I would have a triangle with two 90-degree angles. And that'll never, these two ends will never meet. But since we have such a long hypotenuse, even though this angle theta is very, very straight, it's very close to being perpendicular, since it's going on for so long, it is going to end up meeting our other side. All right, so go ahead and take the rest of today, practice that angles of elevation, angle of depression worksheet. So you guys are going to be doing a lot of drawing these images and solving for angles or for side lengths. So again, if you guys need help or if you have questions, come to my office hours or email me and I'd be happy to help you guys. Have a good rest of your day.